Hi, this is Mr. Warden. I'm going to do a quick video key for the do now today. So we have three triangle proofs. The first one, we have this triangle. I'm going to start by looking at the conclusion. I need to prove that CE and BD are congruent. Okay, so I need to prove that. Okay, so to prove that, it would be useful if I could prove that this little triangle and this little triangle were congruent, or this big triangle and this big triangle were congruent. Now, what I do know is that AC, okay, this and AB are congruent. I know that. I also know that AE and AD are congruent. So I'll pick a different color, maybe there. Okay, I know that AE and AD are congruent. All right, because I know that, a couple things I know. So let me go ahead and start walking through that. So because I know that this is congruent to this, I know this is congruent to this. If I can prove, well, what I can actually, CE, yeah. So I can prove that CD and EB are congruent by subtraction. So after the givens, I can prove that CD and BE are congruent by subtraction, because I'm getting the difference between two congruent sides, subtracting two other congruent sides yields a congruent difference. So I'm going to go ahead and mark that up. So I know that this is congruent to this. Okay. And then I also know that this is congruent to itself. Okay. So let's see what else I can work out. Can I work out that this is congruent to this from this information? Okay. So I know this is congruent to itself. So I'll work that out. Okay. So that is congruent to itself. Okay. So I can prove that this triangle is congruent to itself. Cool. Side, side. I've got side, side. Here's the trick. This angle is congruent to itself. Okay, because this angle is congruent to itself, I can say side, angle. I didn't even need this side. That was extra. So I'm just going to make a note, but that is not needed. Okay, so the simpler way is just to say angle A is congruent to angle A by reflexive. Okay, and once I know that, then I can do triangle CAE is congruent to triangle BAD by side angle side. Okay, so I've got this side here, got this angle, and this side. And then I've got this side here, this angle, and this side. Once I have that, then I actually can prove the final part of this, which is going to be by kappa. I can prove that this side here and this side here are congruent because they are corresponding sides of congruent triangles. Okay, so we can now prove that CE is congruent to BD by kappa. Corresponding parts of congruent triangles are congruent. Okay, number two, let's take a look here. We've got to prove that GJ is congruent to HK. Okay, let's go through the things that we know. We know FH here is congruent to MJ. We know that G here is the midpoint of FH, and K is the midpoint of MJ. We also know that GHJ, So GHJ is congruent to KJH. So these angles here are congruent. Okay, so let's talk about what we need. We need to figure out if these sides are congruent. Now, to do that, it would be useful to prove that these two triangles are congruent. And we can do that. Okay, so let's start doing that. So the givens, after the givens, then we can prove, because G is the midpoint of FH and K is the midpoint of MJ, we can prove that GH is congruent to KH by division, because we halved two congruent sides by defining the midpoints. Okay, so we said G is the midpoint of this. We said K is the midpoint of this. So that means that KJ and GH are half of two congruent sides. So the quotients are also congruent. We know this angle is congruent. Now, if we could just get this side, so let me actually label the new congruent piece. We know that this is congruent to this. And now, if we could prove that this side is congruent to itself, which we can by reflexive, then we will have a side angle side proof. So we can now say that HJ, that is a J over there, in fact, over that corner, HJ is congruent to HJ by reflexive property. Okay, and once we know that, we can prove that triangle GHJ is congruent to triangle KJH by side angle side, because this side, this angle, and now this side are all congruent. Okay, once we've proven that, we can prove that GJ and HK are congruent by kappa kata. GJ is congruent. Oops, GJ. Come on. GJ is congruent to, I'm going to call it KH. Keep the corresponding order the same, by corresponding parts of congruent triangles are congruent. Kappa kata. Okay, there's one more proof in here, and you need to know that an obtuse triangle has an angle that is greater than 90 degrees. So we know this angle is 70 degrees. So we have a given, okay, after the given that's 70 degrees, we can say that AD is a straight angle assumed from diagram, because that's something we can assume. And therefore, we can say that ABC is sup to DBC, okay, by definition of supplementary. And then we can just subtract. We can say 180. We can say, okay, well, here's the statement. Angle ABC, that means angle there, by the way, not triangle, so I'll put that in there. Angle ABC has a measure. The measure of it is 110 degrees, okay, because 180 minus 70 equals 110, okay. Triangle ABC is obtuse because it contains one angle larger than 90 degrees. And you're done.